Hello and welcome to TidyX episode 165, TidyX and Screencasts, where we go through and explain how our code works. My name's Ellis Hughes.
My name is Patrick Ward. Thanks for joining us on another episode of TidyX. As always, be sure to like and subscribe. Hit that button down below. Drop your comments and questions down there. Love to hear from you. Love to get back to you. Additionally, if you enjoy our work and you'd like to support the show, we do have a Patreon page.
Yes.
And so we're always thankful for anything that you'd like to give. That being said, we're going to jump into episode 165. And here Ellis has titled it The Power of Plotting Compels You. And we've talked a lot about plotting. We've done a ton of ggplots and shiny plots and plotly plots and things like that. And one thing we haven't done a lot of is base R plotting. And I tend to use base R plotting a whole bunch in my work. If you've ever read any of Andrew Gelman's textbooks like Regression and Other Stories or data analysis with mixed and hierarchical models, he talks a lot about workflow and Bayesian workflow and the idea of plotting and fitting and plotting and fitting and going back and forth. And he uses primarily all base R plots because you can really quickly get something and you don't have to load any other packages. You can just really quickly get something and
Out of the box
then
in R.
out of the box, look at the data, fit a model, plot it again, look at something else.
Iterate, iterate, iterate.
Iterate. So we're going to go through base R though, and we're going to kind of build up from the basics to like really nice looking plots. And over the subsequent weeks, we'll do different types of plots and we'll show different ways of kind of putting the window dressing on these things. And today we're going to start with a scatter plot because why not?
It's a great plot to start with. And our brains are still a little bit scattered.
Yeah.
Ah. So we're going to get the data in. We're going to use the Lamin package, load this in. Of course, if we really wanted to be purists and only use any data sets that are included in base R and load no libraries, we could have used like the empty cars data set or something like that. But batting is going to allow us to explore a few more options that you maybe wouldn't if you're dealing with those smaller data sets. So we're going to load the library of Lamin, which has, of course, batting and MLB stats and whatnot. We're going to then take this batting data set and using base R, we're going to be filtering this data frame down. So if we take a quick look at batting, it's a fairly large data set. Wow, there, yeah, like many rows here. So we're going to filter this down because we don't want to wait forever for a thing to plot. So we're going to say, hey, any batting year that is greater than 2010 and any batter that has batted at least 100 times, we're going to keep their records. And so this is going to just, give us a Boolean vector of probably a lot of falses because this goes way back in the day. So that automatically cuts off a bunch of people, and then any batters that didn't really bat all that much, get rid of them. Um, and then we're going to say, okay, the columns that we want to keep are the league ID, the runs, and the hits. And so we're going to apply this to batting, and we're going to make our DAT data set here. And so as we can see, it's a fair amount smaller now. It's a little over, just under 6,000 rows. Now, then we're going to drop the levels there from DAT, and then we're going to take a quick head there to take a look and confirm, yes, we have the league ID, runs, and hits.
One of
Let's,
the things with just real quick dropping levels, if we didn't do that, um, I only wanted the AL and the NL because those are the only two leagues that exist in years 2010 or greater. If I don't do that, if I don't drop those levels, they still get retained, even though there's no values in them. And so when we go to plot and we go to color, for example, by the league, those levels are still there. So the AA, the FL, the NA, the NL, the UA, the PL, we don't want those other levels. So watch what happens if we were to run DAT, the filter again, and then we do table by league ID. And you're going to see that those levels are still retained, even though they're zero. There's no, those leagues don't exist in the 2010 or greater season. But we want to make sure that those levels are not accounted for as factor levels within the data if we were to like build models or plot things where we're coloring by the league ID. So I just dropped levels there.
yeah. And
But
this is kind of a hammer, everything's a nail situation.
Yeah, yeah,
where we
yeah,
just applied this to everything. If you wanted to be more specific, legally, legally.
for
If
example.
you wanted to get a little bit more specific, but
Yep,
in
yep,
our
yep.
situation, this works fine. So whatever. So
Cool.
all right, plots. Patrick, how do they work?
Well, a scatter plot is pretty easy. You say plot, and then you say, tell me what you want on the x-axis, tell me what you want on the y-axis. Here, we have to call the data frame and then use the dollar sign and the column that we're interested in. If we just want to call the columns, we could use with. We could use the with function. So there is like a with dat and then a comma, and now you could essentially what you're telling R is, hey, everything I want you to do in the function after that first comma is going to be with the dat data frame. Two different ways.
Yeah.
It's going to get you the same result, but basically what it does is it plots you this little default plot. Now you can see that the x-axis and the y-axis labels are going to be whatever's written
Where'd it
inside of
go?
that plot
Plot.
function.
There we go. That one.
There you go. So in this
Panicking.
case,
Ah.
yeah, right. In this case, it's dat dollar sign H. In the with version, it's going to just be the H and the R, right?
Yeah.
Because it's whatever's there. There's no title. The default is the clear bubbles or the clear circles,
Circles.
and
Yeah.
so that's fine. Great.
It works. It gets the job done.
Let's
Basically, what
let's
it's doing is it's
yeah.
taking the contents that's entered in there as it's entered. That's
Mhm.
important to understand as it's entered.
Yeah.
So that's if you don't do any other manipulations downstream of it. So that's just knowing what you're gonna get is just trying to be very explicit. You said this. Here you go.
Exactly. Exactly. With the PCH argument, we can go ahead and we can change the type of point that we get. So in this case, I wanted dots that were filled in instead of open dots like we had as the default. There's a whole bunch of different PCH options. Ellis, how would we see all those?
Yeah, so plot also gives us a kind of a fun ability to plot a bunch of things all at once. Here I'm going to say is I'm going to create one vector for x that says repeat 1 through 10 times. The 1 through 10, then 1 through 10, then 1 through 10. Then for the y-axis, I'm going to repeat 1 through 10, but I'm going to repeat each value 10 times. So 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2. So basically what we're doing is we're creating a grid, right? Where it's going to basically fill out the bottom layer, then the second layer, then the third layer, then the fourth layer, all the way up to the 10th layer. Um, this is because PCH has a lot of different potential entries that you can pass to it. We're only doing 100 because that's the number that I picked. But there are many types of symbols that you can put here. And it goes from, so the PCH1 is just a dot here, PCH2 is a triangle, 3 is a vertical cross, 4 is an X. But it also goes all the way up to like, what would that
Letters.
be?
Yeah.
87 is M, 80 is 81. Yeah. 81 would be G. So like it goes from just kind of symbols, the symbols that you're like know and love and are used to, all the way up to, various text characters as well. Because they're all symbols, they've all got to be rendered in a special way that the engine in R handles for us.
Hmm.
Thank you, all the intelligent people that worked on that. Um, but each of these PCH symbols also have some capabilities baked into them as well, such as the like you may remember in ggplot how you can color the outside versus the inner circles and whatnot. That is also influenced by these, if I remember correctly. So your choice of symbol not only does it change the like visual appearance, is it a triangle or is it a dot or is it this or that, but it also kind of changes what you can do with it and the options that you have to do with that. I mean, realistically, you're probably going to be working with this lower set, so it's 1 through 35. Wait, one,
Yeah.
two,
Yeah.
so that'd
Yeah.
be
Yeah.
teens.
No,
20,
20.
26, 25,
Yeah, 20.
25. There we go. We are intelligent people, we can figure this out. You're probably going to be working in that space. but know that there's many other ones that exist. So I just wanted to make sure to point that out.
Mhm. We can also change the color with the COL for color. So here we'll go do blue dots.
And note it's not call for column, it's call for color. Um,
Yes.
PCH
Okay.
is like you're gonna notice the argument names are not quite as friendly as some of the other plotting tools you may be accustomed to. There's historical reasoning behind it. I looked it up at one point. I don't remember it, but the key is basically you just work with it and look it up a lot. Documentation is your friend, and there is a fair amount of documentation. So yeah, so that's colors.
Change the size with the CEX argument. So if we hit that, it's going to make things bigger.
Mm-hmm.
Yay.
And one thing to note too, this will magnify everything within the plot.
Mhm,
So there are more fine grained ways to do this, but this is just like for your default plot, this is a great way to do this.
mhm,
It just always, there's always caveats to things.
mhm. We can also add a trend line. So what if we just fit like a simple linear model for runs regressed on hits, and we keep the plot the same. So our plot is what it is. It's going to be gray. And the way that you layer over a plot. So if you think about ggplot, we add the little plus sign and we create our layers. In base R, once we call plot, we're basically free game to do whatever we want until we call plot again. So here we call plot, and then we're going to say, hey, now let's throw in a line on top of this. And we want the line to be the regression line. And so the folks that created this made it super simple where we can literally just take the element name of the regression model that we fit, throw it in there, and it's going to pull out the necessary details. And we're going to plot that regression line in red. LWD is telling us the width. So we want a width of 5. So we want a pretty thick line. And then LTY is the line type, which is a number 2, which is going to be dashed. And
Yeah,
so just like the PCH, there's a whole bunch of different line types that you can create. But this one is our standard kind of dashed line. So that one's a little bit,
a little bit more different.
thicker line. Yeah, exactly. It's
Let's plot it again. So then this is a dash dot, dash dot, dash
long.
dot.
Yeah, long. Yeah, exactly. Long,
So you
short
can
one.
kind of like play around with all them and pick your favorite. Everyone's got their favorite.
And so one is going to be straight, two will be dashed. Yeah.
Yeah, go from there.
We can also do this alternatively by just calling the coefficients directly from our fit. So obviously, the coefficients are stored in inside of that fit as a inside of that fit element. So we can call them directly with the $coef, and 1 gives us the intercept and 2 gives us the slope, or in this case, the coefficient for hits. And so by saying, hey, A is the intercept and B is the slope, we're basically saying A is the intercept and B is the fit coefficient number 2, and that's going to give us the line, and we get the exact same plot
Here,
as you would
just
imagine.
just so you can see that it's different. We're not lying to you. There's the original one. Here's the one now using a line type 5.
Same,
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 same.
same. Okay. What else can we do here? We can color the dots by group. So remember, we retained our 2 levels of league, which was AL and NL, American League and National League. So we passed this little argument called call, and instead of putting a color in there like blue or gray, we actually put the league IDs in there. So this is the string of league IDs, and basically it's going to go through and color them based on each row observation. So red or black is the default here. And then we're just going to go ahead and throw our regression line over the top, this time in blue, so it sticks out a little bit.
Yeah.
Yay.
So this is again reminiscent of when you're doing something in ggplot2 and you set the colors to be based on the discrete values of a column.
Yeah,
Same idea here. Or
exactly.
this came first. I
True,
guess is the better way to think about it.
true.
But
We can also pass bespoke colors. So we could say, hey, we want these 2 special colors. And now in the COL, everything else is the same, but in the COL, I just use that colors element, which is a string of those two color names, and I pass it, I basically assign each of the league IDs color one or color two. And so it's going to assign them now. Each league ID has their own color. And so if we run that, we get some sort of like light reddish and like light greenish. And that's a lot easier to see when we lie our black regression line over the top of that. That's pretty
Mm-hmm.
cool. We can also get separate regression lines. So these aren't going to be that amazing because the leagues aren't that different. But we create a model, and within that model, we subset the specific leagues, AL and NL.
Hey, that intercept.
Oh, yeah, there you go.
There you go. Apparently, it's harder in the National League.
Yeah.
You start off a little bit lower.
Um, no designated hitter either. The pitcher's batter,
There you
pitcher's
go.
bat.
There you go.
Um,
All reasons why. We can explain the data.
So we replot our points. And again, once we hit plot, everything is fair game. So it's going to reset it. And now we're going to lay the AL fit and then the NL fit. And they're going to be relatively similar. You could see a little bit of the deviation there on the intercept, and which causes a little bit of deviation on the right side of the plot where they begin to deviate. But for the most part, pretty lined up pretty much on top of each other. If we wanted to make this a little bit nicer, we could create facets. So in ggplot, we would usually use like facet wrap or facet grid, and that would allow us to create some separation, or maybe we'd create a few plots and we put them together with like patchwork or cow plot or grid arrange, or one of those that we've used in previous episodes before. To do this in base R, we have to basically set the parameters of the plot. And so here, what we're going to do is we're going to say, hey, parameters, we want to make sure that we have one row with two columns because we've got an AL and an NL. And this parameters piece is basically saying everything after that is going to obey these parameters. And you can put other stuff in there, right, Ellis?
Yeah, yeah. So par is basically you're pre-allocating, you're putting the settings for the next series of plots you're going to be doing. And so this is a very powerful tool to be using if you want to create a variety of different types of plots. Here, what we're doing is we're saying, hey, before we go to plot, what we're going to say is we're going to make this canvas. And this canvas is going to have two, well, in this case, two spots. But that's because we have mf row is equal to 1, comma 2. And so this first one represents the number of rows in our canvas that we're going to have content added to. And the second entry is the number of columns that we'll have to. So what we're saying is it's going to be one row with two entries. We could also change this to be 2 and 1. And this would be then 2 rows with 1 column. And so you have some control there. I mean, if you have a ton of plots too, like if you have 81 plots,
91.
do not suggest. No longer very helpful. Your plots will be unreadable by anybody.
Super
But
tiny.
technically, you could do it.
Yeah.
So let's
The
take this
sky's the
back to
limit.
what it was. So we have one row and two columns because we want to facet to have our two plots side by
Yeah.
side.
And when we run this line, nothing's going to happen.
Yep.
So if we run this, you're going to be like, wait, nothing happened. Nothing happens until we call the plot function. Now, as I said before, when you call the plot function, everything's fair game until you call plot again. Here, because we've pre-allocated the parameters of our plot space, everything is fair game. And when we call plot again, it's going to put it into the next area that we've pre-allocated. So here we have our plot one, we have a regression line. Now we have plot two, and we have its regression line. And this is the AL and the NL. You can see on the x-axis, again, just like Ellis said at the beginning, the plot function is going to give you back whatever you asked for. So the x-axis and the y-axis are specifically saying exactly what we typed in, which is dat $hit filter to league ID AL or league ID NL. Same thing for the runs on the y-axis. Totally fine. Let's make this a little bit nicer though. What if we add a legend? So again, we're going to give it the parameters, one row, two columns. We're going to create our plots. And,
So
and
technically, just a quick
we didn't
comment.
have to do this.
You
Yeah,
don't have to do this. So this setting is sticky. It will stay around until you change it, or you there's
turn it off.
a or you turn off the plotting ability, and we'll show how to do that in a second here. But I just wanted to call out this this has been set now up here for the rest of our R session, unless we tell it, hey, no more, no more, go back to normal, or hey, we're done plotting. Um, Done plotting, very strong air quotes around that. Go back to your normal default settings. This is going to stick around. And so that has tripped me up so many times because I will have set something here and then continued on my merry way, went back to doing other coding, and then went to go make a plot. I'm like, ah, no, what is it doing? Ah. And it's because I forgot to turn off the canvas.
Yeah. Yeah, no, totally. Exactly. So we didn't have to redo that, but we can, or I did. We plot everything here is the same until we get to this legend again. Everything's fair game. Oh, we already had one plot in there. So see, this
Oh,
is where you get in trouble.
yeah.
So let's
Let me
reset.
let's just actually quickly show them. So if you're like, oh no, oh shoot, what's going on? I don't want it to be doing things. There's two different there's a quick thing you can do. Dev.off. Dev.off. Run that. Kills your
That's what.
canvas. It goes, bye. No more. Does not exist anymore. So now when you go to plot again, it reverts it back to the original settings. And so this is also good practice if like you're doing a bunch of things in loops and it might be changing the parameters for when you're plotting things. Just call dev off at the very end. It'll clear it out. There's no danger in calling dev off too many times. So let's call dev off again. Oh, null
Yep.
device. The graphic device is no longer found. It got rid of that plot.
Mhm.
Call dev off again. It'll throw an error. So you maybe don't want this in your for loop, but like it's not an error in the sense of your R session's going to die or anything like that. It's just, hey, you told me to turn off the graphic device. There's no graphic device existing.
Mhm.
Ah.
Yeah,
But
right.
now we can go back, set par, set our plot, add our AB line, and now our new fancy
Yeah.
dancy thing,
So the
a
legend
legend.
with this, yeah, here I select top left, but you could select these by specific X and Y coordinates if you wanted a specific place, like, you know, but usually you're going to say like top left, top right, left, bottom right, top, bottom. That'll put it right in the middle. But it could be X, Y coordinates. Here, I'm going to put it in the top left because the top left is kind of barren and we have room for it. So it looks like a nice place to put it without me having to pick an X and Y coordinate. I'm going to put in the legend, AL and NL, and to make the legend specific to the shapes and the colors that we're going to use, I'm going to make sure that I specify. So AL is going to be specific to number 19, NL is going to be specific to number 12, and the colors are specific to those bespoke colors that we set before. And so if we run this, we get a nice little legend at the top. And then if we run the next one, we get the same thing. And I left the legend off because the plots are in the same thing, the same area. We could have put the legend on this one as well,
Yep.
though, just by copy and pasting it down.
Or what you could
Uh,
do too is you could set the legend to be kind of floating up here too. You just need to know the XY coordinates, and that goes down a whole rabbit hole.
Yeah, we'll talk about that maybe later, but setting it outside of the
Comment.
plot
Let us
space,
know if you want us to do that. Let us show you
you have
the
to,
magical
yeah,
ways.
yeah, that's a little tricky. We could finally like make this really nice and add labels and put all the bells and whistles on. So let's say we're going to, instead of turning dev off, we're just going to set us back to a parameter of space of one row and one column. So a single plot. We're going to set those shapes just like we did with the colors. So we have a vector of 19 and 3, and that's going to be specific to the two league IDs that we have. So that's going to set a Boolean vector there in PCH. That's going to be not Boolean, sorry, it's going to be setting 19s and 3s throughout the entire rows. Boom, boom, boom. So those are specific to the league IDs. We're going to make it CEX2. We're going to add our colors in. And now with the labels, we just do simple XLab is going to be hits. ylab is going to be runs, and then the main plot is we have a little regression equation. I use the \n to get a second line that says as players get more hits, they increase their runs. And then the sub function puts a little kind of like subtitle way at the bottom underneath the x-axis. And I'm just giving some courtesy to the package maintainers of Laman. So thanks for that. So make sure we that reference our work there. And that gives us a nice little plot space. Now the NL is the crosses and the AL is the kind of pinkish circles. We're going to put our regression line back on there. We did it by calling specifically the slope and the intercept. And then we throw our legend right up at the top
And keep in mind this
left.
was the fit across all of them.
Yes. And so now we have a nice looking, pretty nice looking little plot
Yeah,
that
it
we can use.
works. I think there's like some maybe a little bit more typing that you might have with like ggplot or some other plotting tools, but also you can like you really get to know like the nitty gritty, how is this being made, what's going on here, and can have some control that maybe you want to have. Or again, because this is all base R stuff, there's nothing that you're bringing into your session or into your environment if you don't have it already installed. So I've definitely worked in areas where we literally couldn't install more stuff. Like there was like the packages you have are the base packages that are included in R.
Yeah.
Have fun. And if you don't know how these base plots work, it can be really painful to try to make very nice plots. But sometimes that's the world that you work in, where it's congrats, you have base R, have fun. Um, and so I think learning at least a little bit of how they work so that when you come across the situations, you're not blindsided is a very
Mhm.
valuable skill to have, or
Um,
just some good knowledge to have.
they also make, and again, as we work through these, we'll show different plot types and different ways of dressing these things up. But they make nice little looking plots for research papers. And also, these plots work inside of Shiny as well. Even though we tend to think of Shiny as sort of like even though it's not part of the tidyverse, we think of it as like that kind of like piece of the R coding world. Uh, you know, but these are plot these base R plots, they work really well inside of Shiny as well. You can build all the types of things that you want with them, and so you can do a lot of cool stuff with these. So they're fun, and we're going to play with these over the next few episodes.
Sweet. Yeah, let us know what you guys think. What are some plots that you'd love to see us create? What are maybe some unusual plotting libraries that you've used that you wanted to learn a little bit more about, but really haven't had a use case for? We come up with use cases all the time here, so we'd love to hear what is an interesting plotting library that you've used or wanted to use and haven't done that yet. Um, so with that, I guess we're going to call episode 165 of TidyX. Thank you all so much for joining us. As always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on X at OSP Patrick at tidy_explain is where the screencast lives on X. Of course, the easiest way to hit us up though is YouTube. Hit that like and subscribe button. Drop your comments down below, questions, things that you'd like to see um, in future episodes, and we'd be happy to jump on that. And again, we do have a Patreon page if you'd love to support the show. We appreciate that, and we're always thankful for anything that you may want to give in support.
Thank you all so much. Keep on exploring your world.